Hello my dear students, welcome back to my class. In the series of learning data structures through C, in the previous video we discussed about the algorithm of binary search and the tracing also with example. Well, in today's video we will see the complete program of binary search with execution. So those who are new to my channel, please subscribe to my channel and click on the bell icon so that you can get the notification of all the new videos. Watch the video till the end. Do not skip the video. And if you like the video, please click on the like button and share the video to all your friends. Here we go with the first portion of the program where we declare all the supporting variables. The array variable, that is the array name is A, and the limit n, the search element, location, beginning, ending and mid position, and the control variable I. So we are going to accept the limit of the array. So let us say the n is equal to 5, that what we have accepted, and we enter 5 elements. We are going to store that in the array, the 5 elements. So a of 0 up to a of 4. So we are going to accept the 5 elements. Then we also accept the search element. Say for example, I say 10, 20, 30, 40 and 50. Say the search element is 30. Let me take the search element is 30. Then some initializations we are going to do here where we set the location to -1, beginning which is 0 and ending which is n-1. N is 5, 5 minus 1 which is 4, the last element. So some initializations we are going to do. Then we have to start the actual logic for binary search. So here we have the next half of the program where we have the actual logic of binary search. So we have already accepted the elements, the n size, search element, and we have set beginning equal to 0, ending equal to 0, and we have also set location equal to -1. The previous half portion of the program, that what we saw. Now, for the binary search, the criteria is, if we want to search the element using binary search, the criteria says the elements must be in sorted order. So while inputting the elements, we must make sure that we have to input a sorted array. So the elements must be in sorted ascending order, say 10, 20, 30, 40 and 50. So beginning we are setting it to 0. So beginning is 0, ending is n-1. So we have to set these two initial values because based on these initial values we have to start the loop. So we start with the while loop. So let me write the iterations here. So the iterations are like this. I say beginning less than or equal to ending. So I need to check the array bound. So before I start applying the binary search technique, the technique, what it is going to do, all these things we have dealt in the previous video. Please do check out the playlist of binary search, tracing and algorithm. There you will understand what actually happens with binary search. So initially we need to check whether we are within the array bound. So what is beginning? It is 0. Less than or equal to ending. What is ending? It is 4. So is 0 less than or equal to 4? If this condition true, I need to get inside this complete block. The first task that what I need to do is, I need to find the mid position. It is beginning plus ending divided by 2. So this is beginning and this is ending. 0 plus 4 divided by 2. So it is 4 divided by 2 which is 2. So the mid value is 2. So now I can say the mid position is 2. Let me write it here. Mid is 2. Next, after finding the mid position, means why we need to find the mid position? Because we need to divide the array into 2 parts. So we found the mid position. Then I need to check is the search element, which is 40, equals to element in the mid position, a of mid. What is a of mid? Mid is 2. What is a of 2? A of 2 is 30. That is, search element is getting compared with the mid element in the mid position. Search element is 40. Element in the mid position is 30. Is 40 equal to 30? No. This condition not satisfied. So this block will not be executed. I'll come to else. I'll check. Okay, if it is not equal, check whether that element is less than the element in the mid position. Is search element 40 less than the element in the mid position? Is 40 less than 30? No. Condition not satisfied. So this immediate statement will not be executed. If it is not less, means to say it is greater. See, elements will be in sorted order. All the lesser elements will be towards left and the greater elements will be towards right. My search element is towards right. Okay. The search element is towards right means I have to move towards the right portion of the array. I have to forget about the left portion of the array. So when I move towards the left portion of the array, so 40 is less than 30. 40 less than 30 condition will be checked. Condition not satisfied means it is greater. So this immediate statement will be skipped. Go to else part, execute this, where I need to change the beginning value. Just analyze this. When I say the element less than 30 condition evaluated as false means it is greater. The search element is greater than the mid element. The search element is greater than the element in the mid position. When it is greater means I have to move towards right. This technique I have told you, greater R, move towards right. When I am moving towards right, the ending position remains the same. Beginning I have to change. So I should change this beginning value. So hence I will come to else part. I say beginning equal to mid plus 1. So what is mid? It is 2. 2 plus 1 it is 3. Now the beginning pointer is changed. Now the beginning is not here. I have to only concentrate on the right portion of the array. When I go to the right portion of the array, ending remains the same. Beginning I need to change. So it is mid plus 1. This statement gets executed. So mid plus 1 means it is beginning is 3. Beginning is 3 now. So beginning is 3 and ending is 4. So after this I need to loop back. I need to once again check the condition. What is that condition? I need to check whether I am within the array bound. So what is the beginning value? It is 3. Ending value it is 4. So am I within that array bound? Yes, I am within that array bound. So I need to check that. Loop back means check that value. Beginning is how much? 3. Ending is how much? 4. 3 less than or equal to 4. Is 3 less than or equal to 4? Yes, condition true. Once again get inside. Calculate the mid position. Mid equal to 3 plus 4 divided by 2. So it is 7 by 2 which is 3.5. As mid is of integer type, it will take only 3. 3.5 means only the whole part 3. So mid value is 3. So I need to write the mid value now. Now the mid is not pointing to 2 but the mid is pointing to 3. So both beginning and mid are pointing to 3. So I found the mid position now. So both beginning, mid are pointing to 3. Ending is 4. Now I need to compare this search element 40 with the mid element. So mid position I have found. Check the condition. Search element equals to A of mid. Mid means how much? It is 3. What is A of 3? It is 40. Is 40 equal to 40? Yes. Condition is true here. So this block gets executed. See, I am only concentrating on the right portion of the array. This left portion of the array, I am not touching that left portion of the array. I only have to concentrate on right portion of the array because the right portion of the array I have set beginning and ending. So I am within that bound. Find the mid position. Once again compare the search element with the mid position. Yes, it is getting compared. So this block gets executed. This condition is true. This block gets executed where I store the value of mid which is 3 to location. So location becomes 3. So I got my search element. Search element is 40. 40 is found here. What is the position? So location which was -1, now it is changed to 3. Location is equal to 3. Then after this block, I need not come to this else block. Loop back. Loop back. Now, what happens when I get the position? Should I have to loop back here? Look at here. I say location equal to mid. But there is one more statement that you have to observe here carefully, which says break. What the break will do? It will not allow you to loop back. It will not allow you to loop back. Break says you terminate the loop. See, this condition was true, so this block has to be executed. I say location equal to mid. The value stored in mid will be transferred to location, so location becomes 3. Then what is the statement here? An unconditional branching statement is there, which is break, because once I get the position, I need not traverse further and do the searching process, right? I have to simply grab the position and I have to stop the iteration. So in order to stop the iteration, we say break, where I need to come out of this loop and the control will be to this point. So when I say control to this point, it is location greater than or equal to 0, I need to check. What is the new value of location? It is 3. Is 3 greater than or equal to 0? Yes, it is greater. I get a message. The output is position equal to percentage D, print the value of location, which is 3. Got the answer? Position is 3. And then the program ends. So this is what with the binary search program. So here you have also the assignment. You can also check with the right portion. You can take the search element as 10 or 20, or you can also take the search element as the element which is not available in the array. You can just say 60. So here what happens? The location will be -1 itself. Then I get a message search is unsuccessful. If I go to the left portion of the array, the beginning remains the same, ending I need to change. So you can just do this tracing with some few values, and please write down the answer in the comment box. So I'll just change the search element as 20, search element as 60. Try to trace out for these two search elements. So let us see the execution of this program now. So here we go with the program to understand binary search. So we have the array declared A, element I, N, location, beginning, ending and mid position. So we'll enter the limit, enter the elements, enter the search element also, and these three initializations we have to do it, which is location equal to -1, beginning equal to 0 and ending equal to n-1. And this is what the complete logic part which will do the binary search process. So we find the mid position, then we compare the element with the element in the mid position. If it is true, then we simply grab the location and will terminate the loop. If not, we check whether the element is less than the element in the mid position, then end equal to mid -1, else beginning equal to mid +1. Then finally, we are going to print the position. So let us save this program. Run the program. So enter the limit. Let me enter the limit as 5. Enter the elements. Say elements. While entering the elements, make sure you are going to have a sorted list of elements. So 10, 20, 30, 40 and then 50. Search element, I'll say 40. Now, yes, position is equal to 3. Now let me also give the search element which is not available also. So once again run the program. Enter the limit, I say 5. Elements say 6, 7, 8, 10, 14. So enter the search element, I say it is 11. So what is the message? Search is unsuccessful. So this is what with the binary search method. Hope you have understood with this. That's all for today's video. See you in the next video. Till then, take care. Bye bye.